Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Dorma. This is their part number CP1000. That's a CP1000. It says AMS 626. AMS I would know to mean all machine screws. And we have machine and wood screws, so unless I discover that AMS means something else, it means all machine screws. So it's a CP1000. So first we're going to start with a visual tour of the item. Then we're going to talk about where you're going to use it. We're going to then look at all of the supporting documentation that we have, and that'll be that. So this is the business end of a CP1000. It is basically a floor plate that has an area where you can insert the spindle into it. There are different spindles for this type of hardware, what's nice about that is that they're modular. You don't have to special order a pivot made to a specific requirement for spindle length. Why would you need? Well, we'll talk about why you need a longer spindle. But this is affectionately known as the business end. The base, the width, about 4 5/8 or so, 4 11/16. The length about 5 1/16. The overall height, I'd say you'd be right at about, 2 inch, 2 1/4 inch. And what you're seeing here are lugs. We'll talk about those lugs in a moment. You're going to have your finish plate. That will cover that off quite nicely for your installation. Obviously, you can get that plate and all of the architectural finishes and sprayed finishes as well. You will have your collar that will sit there as well. Your spindle is going to drop inside of here. It will be secured with a bolt. Now at this point that pivot's probably starting to look like something you recognize. And then of course your arm is going to fit down onto all of that. That's just going to drop right onto your spindle. Now you got a bottom spindle. And by the way, the part number is easily, it's quite easily dissected. CP, it is a center pivot. It's a center hung pivot is what it is. 1000 is its weight rating. So if we were talking about a CP 440, 440 pounds. Because it is a backup, the bolt that's going to hold the spindle on, a variety of fasteners and screws and whatnot that you'll need for everything. Then of course you're going to get a top pivot assembly. This pivot is 626, by the way. That means it's satin chrome. That really means that this is made of brass and a satin chrome plating with a lacquer applied. The plate on the pivot is also going to be in the same type of finish. That's a peel away protective film that's there. This is called a walking beam pivot. Right now the pin is basically retracted. As I rotate that screw, I can draw the pin down, and now you start to get the idea of how these are installed. Super easy. Okay, that's how that works. Then you're of course going to get the door portion of all of that. So that will be mortised into the top of the door. Okay, that's how all that works. Really neat stuff. So that's all of the physical hardware in the box. The length of the top pivot for the header is about 6 1/2. The door portion is about 5 7/8 or so. Just putting some scale on all of this, I suppose. So at this point, the only thing that you've not seen are the documents that will come in the box. Basically, there'll be an installation instruction with a technical drawing on the other side. All of this should be linked to down below this video as well. So now let's talk about exactly where you're going to use this hardware and some of the nuances of a CP1000. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, what would you use a CP1000 for? Well, it's pretty obvious something that weighs a lot, something very heavy, something up to 1,000 pounds. So the pivot itself will handle that 1,000-pound type of door. But where you will use a center hung pivot is more detailed. It's more of a science that you accumulate as your experience in the door hardware industry expands. CP, center hung pivots, that is a reference to the location of the vertical axis of pivoting. There are offset and center hung pivots. The center hung pivot means the imaginary line, the vertical axis of pivoting, goes down through the center of the thickness of the door. You wouldn't bias it towards one side or the other. You wouldn't do that. Your door is going to be here. Now you could take that vertical axis of pivoting and you can move it in this relationship. You can install it in the floor towards the jamb according to the template location, or you can take all that and scoot it over. There'd be no problem doing that. I've literally had people take pivots like this and make what we would think of as a revolving door. Move the vertical axis of pivot down into the center. It's literally a 78-inch wide door, and the customer wants one that looks like a revolving door. Got it. I mean, it will only swing basically 90 degree, but it's kind of neat in that regard. And you'll see a lot of those types of applications out on the West Coast. California is not uncommon for those applications. So when you need to have the vertical axis of pivoting in such a way that you wish to hide or disguise the hardware, you'll think about center hung pivots. Because you're moving that vertical axis of pivoting down into the center of the thickness of the door, there won't be a knuckle sitting outside of here like there would be with an offset pivot. And the offset is the dimension from the face of the door to that vertical axis of pivoting. Those are either 3/4 or 1.5 inches. Those are offset pivots. Center hung pivot, that's down in the center of the thickness of the door. And people will elect to have those because they literally don't want to see the hardware. And while you can technically see the hardware, if you open the door and look down, you'll see the finish plate. And if you look up, you'll see the component in the header. But from an elevation perspective, you don't see the hardware at all. Now, having a center hung type of door creates its own areas that you have to address, be concerned with, or otherwise work around. Because if I had a swinging door, and my vertical axis of pivoting is out off the face of the door like it would be for a butt hinge, I don't have to worry about anything. Well, for the most part, if my door goes to 90 degree. But if I try that trick with a center hung, now my rotation is such that my door could end up hitting the jamb based on it just simply rotating. So doors that are hung on center hung pivots, or center hung floor closers, or overhead concealed closers, you have to take into account that you'll have to either treat the edge of the door or leave the gap between the jamb and the edge of the door heavier, because if you've got a square edge piece of block going through there, you won't have enough room. And all of this can be plotted into AutoCAD so that you can figure out exactly where you need to locate the vertical axis of pivoting based on where that is from the jamb and how thick your door is. Okay, which is another thing to be concerned with. How thick will the door be with this? It's going to work with a typical 1 3/4 thick door, but technically there would be nothing stopping you from installing a much thicker door on it as well. So the differences between center hung and offset have to be thought out, because center hung has its own associated baggage or implications. When people want to conceal and hide their hardware, that's fine. How are we going to contend with the fact that we're not, or maybe we are, bullnosing or radiusing the door? If we're bullnosing it, the door is going to swing in one direction. If we're radiusing it, it'll swing in two directions. Like if my fist is the outside corner and my vertical axis is over here, you can get the concept easier. I've got a margin there, but when I go to rotate that, you can see I lose my margin, and I've not changed my positioning. So that's what you have to think about with a center hung pivot. Now, people who will buy a CP1000 or something in that range, a CP660 or a CP440, very oftentimes they're not hanging a door. They're hanging they're hanging a bookcase that is basically a door. So it's a hidden It's access to a room behind, but the front of it is literally a bookcase. And because you can take a bookcase that's just 30-inch wide or 24-inch wide by, say, 72-inch tall, and you can load that with books, it's going to be hundreds of pounds by the time you're done. So you'll need a pivot that's capable of the weight, and you'll need to probably think about how severely you will end up building, constructing, and otherwise reinforcing the bottom of such a bookcase. But hardware like this is going to be very typically seen in that application. Exterior doors and center hung is also problematic when it comes to weather stripping the material. So you have to think about where you will weather strip the material. It's a classic problem. Now this hardware in particular, I'm going to remove the spindle and the cover for it. This one here has these lugs. That's how this is meant to be installed.
I found this on the web.
And what that means is the way this was tested is not to be screwed down to the floor. No. This is meant to be put into a box that's filled with mortar and this placed into a box of cement. That's how this is meant to be installed. And I've had people ask me, well, can't I just remove those studs and screw it down? Sure you can. It's not the way it was tested. There's no way to know that it's still going to hang a 1,000-pound door. A 1,000-pound door and some grade 2 zinc-plated wood screws is not how Dorma tested this. They tested that certainly in a bed of concrete is what they would have done. Can you remove those spindles? Sure, you can. People have done it. I've never heard of a failed application, but all bets are off when it comes to what it will actually hang. So people do that all the time. But that's what these are for. They're meant to give you surface area in a bed of concrete. Okay. Now, as I had quickly demonstrated earlier, that spindle is going to be screwed into the rest of the unit. An Allen wrench is just going to tighten that down, and then you're in real good shape. You're going to drop that arm on there, and you're in real good shape. Now hanging this is actually quite easy. These pivots are easy in the sense that hanging them and removing them is a simple task. Doing it by yourself is probably not a good idea, especially when you're dealing with heavier weight doors. Of course, a door that this is going to be hung on or a bookcase is not going to be something you do alone. But the bottom line is the way that these are hung and unhung is that you pull that pin up, as I had demonstrated kind of earlier. You're going to rotate that and draw that pin up. At which point, once you rotate that all the way up into the housing, guess what? That door is just going to tip right out. And then at that point, you and one other person are now going to lift that door off of the spindle, and it's going to come right off. So whether it be a center hung pivot or an offset pivot is the similar concept. You have to remove the studs that are in the top pivot and any intermediate pivots. But then at that point, the door will tip out and you lift it right up and out. By the way, there is no function of intermediate pivots with center hung. They just don't exist. Only on offset hung pivots would you have a intermediate pivot. And that's a downside of center hung pivots in the sense that if you have wood doors and let's say CP440 Dorma pivots and you have a warp condition, it's not on the hardware, that's going to be considered improperly hung. You don't have any intermediate product helping keep the door straight without warping, so be mindful of that as well. I've had customers do center hung pivots and the doors warped, and there was nothing I can do for them about that. They are warped because they're technically improperly hung according to the the pivot manufacturer, according to the door manufacturer. That's not according to the distributor, and whoever specified the material ought to have been aware of that potential fatal flaw when it comes to center hung pivots. So we're going to go over the installation instructions and we'll talk about that, but at the end of the day it's really easy. This is nothing other than a rectangle. How long, how deep, how wide? You're going to mortise that into the bottom of the door. You're going to do the same up in the header for this. How long, how deep, how wide. It's just router work, corner chisel work. And the only thing you have to do is to be sure that you are putting the vertical axis of pivoting off the jamb or the edge of the door, whatever the template and instructions call for, at the proper distance. You have to then make sure that where you install that top pivot, that a imaginary plumb line is drawn down, and that's exactly where the bottom spindle is going to be. That line has to be plumb, perfectly plumb. When doors are hung, they have to be true, plumb, level, and square, and they have to be plumb, most absolutely. You'll want to use a plumb bob to drop from your, you'll want to do the top component first, drop a plumb bob down and mark exactly in the center, because what you're doing is you have a bed of concrete there, and you're going to position that bottom unit exactly where it needs to be. It's going to be braced in place so it can't move. Or if you happen to be going off the menu, so to speak, or the reservation and screwing it down, you'll have to place that exactly where it needs to go. So why don't we switch to the screen view, and let's look at a oppressive amount of supporting documentation. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's take a look at a couple of dozen or more images that we have of the hardware. And these are all down below. There's the label. There's everything in the box. Bottom portion, cover plate, spindle, collar, bottom arm, top pivot assembly here with its screw package. The screw, the bolt to hold the spindle down into the bottom assembly. Allen wrench, which I think is for this screw. Screws for the cover. Screws for the scalp plate. Machine screws for, I don't know what those are for. This screw package is for the top. This and these are for the top pivot assembly. I don't know what these are for. I can't imagine they endorse removing these studs in the installation instructions. Just showing you different perspectives on this hardware. Let's look at some more photos. Top pivot assembly. Door portion. Just machined aluminum is what that was. Floor plate. Spindle. That is a particular part number, and I'll show you in the catalog where you can find in the catalog other spindle lengths. Now, why would you need other spindle lengths? Well, imagine if you had a situation where you've got a floor, you've got a door, okay, so imagine if we have a situation where well, this, you get the concept. This is roughly what all that looks like. Your spindle, your arm is going to be in here. The bottom line is your clearance, which is the dimension from the bottom of the door to the sill. That can be lots of different things. Maybe it's really tight down to the bottom, or pardon me, maybe that it's really tight down to the door. Or maybe there is a situation, and this is very common, where you're going to install the hardware, but you know that there's going to be 3/8 of an inch worth of floor that's been poured in here. So you're going to need an extended spindle for that for sure. Maybe a terrazzo pan type of concept where you know there's going to be a flooring condition. Maybe you inherited a job that had a very thick flooring, shag carpeting, wood floors, that's all been removed, and you decided not to replace the doors. You might need a longer spindle for that. So lots of reasons why you'd need a longer spindle. But again, what's super nice about the Dorma approach is that those parts are modular. You can just order up a different spindle with a different length rather than having to get a factory manufactured item. Collar. I think we've got a little bit more here. Yeah, screw package. Then your installation instructions. Okay, so now looking at some supporting documentation in no particular order. Let's look at the cut sheet. The cut sheet, center hung, single or double acting. What's nice about the way that Dorma approaches this is that it's very modular, their parts, in the sense that they'll use a 7471 HD for different applications. So they're going to use it in the CP660. When we look at the product catalog, you'll see all of the drawings like this. Okay. Now, what they're showing us here is, we know that this one is the CP660 and this is the CP1000 because it has a 4, a 2, and a 3 in it. And it's showing us what our, not only what it's going to look like in a line drawing sort of perspective, but the part numbers for the constituent pieces, which means, yeah, you can order the 7417 HD if you need only that. So that's the cut sheet for this. The next document is going to be called the cross-reference chart. This is handy because it will allow you to understand what Dorma part number you would use if you're converting from a Rixson part number. If you know pivot part numbers, you probably know the Rixson numbers first. So if you're looking for an H117-3/4 capability, that's going to convert to the CP1000. Then we've got a selection chart, and what they're showing us down here is, oh, this is a great document. This shows us what I was driving at earlier with the vertical axis of pivoting. It also shows us a 3/4 inch offset hung pivot. Again, 3/4 inches from the face of the door to that center line of the pivot, and then 1.5 inches. There are 1.5 inch offset pivots, and you would use that greater offset generally to contend with a deeper inset or a clearance condition, or occasionally I will even use it as a way to contend with a thicker door but a much lighter door than standard. And also I've used it earlier this year, or maybe it was last year, to contend with an archtop door. And the archtop door was set into the face of the wall by 3 inches. And what happens there is when that door opens, because of the arch, it will make contact with the arched preparation in the face of the wall. So throwing the vertical axis of pivoting out further allows you to get out and around the fact that the door when it goes to open from here to here, it's going to hit the arch up in this area, and moving that vertical axis of pivoting from, let's say, here to out here, from here out to here, it allows you to clear that. And the door would normally sit right in here, and it's going to strike somewhere in this area. But when you move that vertical axis of pivoting from here, say, over to here, you then won't really hit the arch, depending on the inset. But I've used it recently to success to solve that. This is also a pocket pivot, which is a specialty hinge, which we're not going over obviously in this video. This would be called a Harmon hinge as well, and pocket hinges or Harmon hinges are great because they get the door completely out of the opening. Here's your stop. Right here. Well, this is the stop. This is the soffit. So when you open the door to 90 degree, the door is completely out of the plane of where the stop is, allowing you to more easily go through an opening with something like wheelchairs and other hospital type applications. But this selection chart down here is the quick cheat sheet that will show you what pivot to use based on the weight of your door. And obviously whether or not it's fire rated, that's important. You'll note that there are no center hung fire rated pivots. They're only ever offset hung. So Dorma only makes 4 models of, well, actually 3 models and 1 derivative of center hung pivots: 440, 660, and 1000. They have many more in terms of the offset pivot world, but you're going to start with what's the weight, choose accordingly. That's all there is to it. The next document is going to be, these are going to be templates. And I think what we'll do, since we're going to see these with the installation instructions, we'll address them in that fashion. This is the entire product catalog that we have here. Actually, I do have pictures of the bottom arm that I didn't show you. Which I'll show you here. That's the face that goes to the bottom of the door. Another perspective. Side view. This would be the bottom. Close up. And then the underside. And then a picture of the top pivot with its scalp plate. Okay. Now the product catalog, not many pages in this, maybe 15 or so. Yeah, 16. So LM series pivot sets and components. Let's take a crack at this. Dorma pivots support door weight effectively in a variety of applications. And I'm just going to scan this to point out anything that's important. Array of finishes. Long life, trouble-free operation. Yeah, that's the hallmark of pivots. The earth is bearing the weight of the door, not the hinge or the hinge knuckles. All that being transferred to a jamb. It's the earth that's supporting it, the floor, the ground, the bottom pivot. Rated for high traffic interior and exterior openings for both rated and non-rated openings. Extra heavy doors, lead line doors, absolutely pivots are great for that. 20 and 3 hour minute fire rated applications. It can be used on wood, aluminum, and hollow metal doors. Specialty design doors as well, like that revolver we were talking about earlier. Durable and long lasting, no doubt, up to 1,000 pounds. You can get them center hung, 3/4 offset, 1.5 offset. Floor bearings with numerous spindle heights are available to accommodate an array of door choices and flooring conditions. Center hung walking beam, top pivots, and bottom arms are mortised into the door. Floor bearings are surface applied or grouted into the floor depending on which pivot set floor bearing is used. Pivot sets available from 200 to 600 pound versions, heavy duty versions up to 1,000 pounds. Center hung pivots and pivots can be used on single acting doors or double acting doors. So inherently a center hung pivot that door is going to be able to swing this way or this way. It can go 360 degrees like a revolving door. But if you're going to make a center hung pivot into a single acting door, you're going to want to apply an auxiliary stop or something there if you want that to only go in this direction. Is how that would work. Okay. 3/4 offset pivots are available for non-rated and rated. Pivot sets use full mortise pivots. Yes, nothing surface mounted. Optional intermediate pivots are recommended for use with pivot sets, meaning offset pivot sets. Side jam arm is available for conditions where floor preparation is not desired. They're talking about a type of offset pivot where you don't attach anything to the floor. You do so to the jamb in a condition where you would want that would be radiant heat in the floor. You would certainly not want to pierce through your floor with screws. Lead line door pivots and pivot sets are available for varying door thicknesses. You can read about the 1.5" and the pocket pivots. These are bullet points, technical details of kind of what we just went over. They meet the requirements of the ANSI BHMA A156.4. That's a standard that you can actually read. That's available from ANSI BHMA. UL listed where it's appropriate for them to be used on rated openings. Finishes. Plated finishes are here. Prime coat, bright brass, satin brass, polished bronze, satin bronze, oil rub bronze, bright nickel, satin nickel, bright chrome, satin chrome, aluminum, dull bronze, dark bronze, well, statutory, and then dark bronze, gold, and black. You've got 3 shades of bronze there, really. This is the cross-reference chart that we had talked about earlier. That shows your center hung. We also looked at this drawing earlier as well. The cut sheet we looked at earlier. Now, because this is the product catalog, they will all be here. Here's your lead lined. OPL, that's only going to be a offset. You really wouldn't do a center hung lead lined application. It's just, you need a stop on the frame. When you're doing a lead lined application, let's use part of our drawing here. You know, when you're going to do a lead-lined application, there's different ways that doors are built lead-lined. The lead can be in the center of the thickness, or it can be underneath here. But regardless, when you have a lead-lined frame, you're going to have lead wrapped all inside of here, so that there's really no angle that lead can penetrate through the opening. It can't, you know, you've got lead all the way through here. You can't penetrate this way. You can't penetrate this way. There was a case where there was a dentist office built, and one of the walls, it was discovered, the secretary over time started feeling sick. It was exposure to all the x-rays, and it was determined, it was absolutely found, there was not lead-lined drywall on the wall that the secretary sat on. So, yeah, lead-lined stuff has to be appropriate. This is going to show the top pivot, your bottom arm, part numbers for that specifically. I think ours was an HD 8062 on our CP1000. 7421, which is the arm that you'll get on our CP1000. You've got a 7422. It's a bottom arm, but for an aluminum door. And you're going to have these screws that will allow you to adjust the cant of the arm inside of the door so that you can tip that door, you know, 1/2 of a degree or whatever you need. Top pivots, here's our HD 8062, that's here. Now, the 8062.5, that's going to have a 1/2 inch diameter pin. 8062.5. I don't know where that's going to be used exactly. Except to say that that's the standard pivot. So that's going to be used everywhere, except when you have, you can go back to the cut sheet and you should be able to find that listed in lots of places. You can do a power transfer, apparently. Is that what they're showing here? Yeah. You can run 2 or 4 wires through a top pivot if you needed to get power into the door. You can do it through the top pivot. What would be power in the door? It would be an electrified lock. It could be, you know what it could also be? It would be the type of glass that turns opaque when voltage is run into it. I've seen that in the past as well. Offset pivot drawings, we'll skip through that. Oops, I'm sorry. Inch and a half offset. Parts, floor bearings. We're not dealing with this at all, but this we are. Now, here we go. Interchangeable spindle extension. So the standard is the 74005. Clearance provided under door 3/4 inch. We're going to be able to go over that. Well, actually, let's just go over it now. There's a couple of terms that I would point out to you. Undercut and clearance. Here's your frame. Here's your door. Here's your frame, your jamb. Undercut is the dimension from the bottom of the door to the bottom of the jamb. Clearance is the dimension from the bottom of the door to the top of your flooring condition. So you might have a 3/4 undercut, but after you add, 1/8 inch vinyl tile along with mastic, that's your clearance. That's important to understand the distinction. And then, as you can see, you can get greater clearances by having a longer bottom spindle. These are pocket pivots, which that's a very different video altogether. Nice to take a look at, though. Now, let's move into the installation instructions, which are here. Let's do that now. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. Let's dive into these installation instructions, and these documents are in they're in the package, and it's going to be a matter of taking that paperwork out and then of course reviewing it. So because these pieces and parts are modular, there's not an installation instruction set for a CP 1000. It's going to be broken up into the bottom assembly, the top pivot assembly. Certainly it'll be broken up into, and probably the arm for the bottom as well. So first document that I've pulled up here is the 7471 HD heavy-duty floor bearing. This bottom package, what's neat about that is it's going to be used on all of the types of pivots that are rated for this weight, whether it be center hung or offset hung. And what changes are the arm, and that's what's really nice about this. Certainly from a perspective of being a distributor, it certainly does make life easier in terms of how you inventory material. So let's move on with looking at the floor and the instructions for the floor portion. So there's not really a lot to say in terms of instructions, because I think the approach is that it's self-evident. It's obvious how to install it. And there's really not a lot that you need to know about this in terms of it being encyclopedic in length. It's just place it in the right location, install it using the means appropriate, and you're in, you're out. Make sure spindle center line is in proper alignment with top pivot. Okay, so, I mean, that is, in the world of pivots, there's one commandment, and that's it. Bearing should be grouted in place so that it is square with frame, level in all directions, and top of cover plate will be flush with the finished floor. So, installing it appropriate as to the application. Installing it so, based on how it's called. When they're saying level in all level in all directions, you've got this thing sitting here. Okay, the other spindle stud that's here. It's got to be level. When you're looking at it from a plan view, that plate's sitting here, it's got to be level in every possible angle. I mean, it has to be level, completely level. Obviously, where you... Wow. You got to have a plumb line here. It's got to be utterly plumb. For threshold applications, drill an 1.25 inch diameter clearance hole through the threshold coinciding with the spindle location. That would be an instance where you might want a longer spindle. Top of floor bearing cement case. Top of floor bearing cement case is flush with finished floor line for threshold applications. Yeah, I mean, you know, the top of the body's got to be flush with the floor. You're then going to put a threshold over it. Anchor floor bearing first, then the threshold in a usual fashion. Attach spindle screw using 5mm hex key. Okay. Now what follows here are dimensional drawings. So let's rotate these so that we can take a look at them. And when I first started installing mortising doors for pivot hardware, there were no instructions. It was just, here's a drawing, and everything you would need you could glean out of the drawing. So this is clearly showing an offset application. How do we know that? Because it's indicating arm types here, and plus you can see it's offset 3/4 inch. This is not our center hung pivot application. This is an 1.5 inch offset. You can see that. And what's nice about all of these pages, they're giving you all of the dimensional properties of everything. And this is really where you pay attention to what you're doing. This is the page. This is it. This is everything. And in fact, those notes on the instructions could have just been put right here. So what's crucial? Well, obviously you have to set this unit down in mortar, which would very likely be you're going to need to build a cement case or a box to set this in. Okay. Once you have that, and they don't give guidance in terms of that, but you have to, follow the instructions. And the instructions clearly indicate bearing should be grouted in place so that it is square with frame level in all directions, and top of cover plate will be flush with finished floor. So, they're not telling you what to do, and nor do they offer a cement case for this, which I would think they ought to. They ought to offer something that you can get placed into the floor and then grouted in place. So what's crucial? Obviously 2 3/4. From the jamb, the cased opening frame, to the vertical axis of pivoting, 2 3/4. You're going to center your door over this. Would there be a reason not to? Well, I can't think of one, except if you had an unusually thick door and it was single acting, you might bias that in one direction so as to minimize how much you need to bullnose one edge of the door, but that's just imagination I'm using. All the other dimensions for the overall height to the bottom of the lugs, the center of the lugs, where you're installing all of it. And this is it. There's nothing else to add to this. Create a box, set this in mortar, make sure it's level in absolutely all directions, and 2 3/4 from the jamb over. How will you ensure it's level in all directions? Well, what you could do is create a fixture that I'd have to think about this for a minute. You know what you could do? Let's take a look. Yeah, you know what you could do? I'm not Mr. Wizard on thinking this up, and it's because I've seen it. And I'm surprised that Dorma doesn't have something, but let's do this. Okay, so keep in mind the floor plate. You've got 4 holes here. That's to hold the finish plate down to the body. And what we see here are 4 holes that are tapped right here. What you could do is create yourself a piece of metal that will be drilled and countersunk for you to insert the machine screw into I'm just thinking out loud. You could create a piece of material, a piece of metal, that is shaped like an X. So we've got our body, we've got our 4 holes for the finish plate, and we've got our big spindle. You could create a piece of metal okay, and attach that down so that when you plop that into the bed of, to the, 5 inches deep of grout, these pieces of metal are going to rest on the floor, ensuring that you are flush. So you could do something like that. Just making up the idea, but yeah, you could consider that. That needs to be flush. So the question is how will you do that? I'll tell you this, being lazy is the mother of invention. I would most certainly have a fixture that was 2 3/4 over to here, my jam, and I would place my steel right up against it. You might even get super lazy and make this piece of metal like, oops, like this. Forget that line is there, so that you could literally square it off to that corner. If you know that you're dealing with 5 7/8 jam depth cased opening hollow metal frames, you could easily make that for yourself. So now this is your piece of metal. All of this, all of this. That's your fixture. Make your own fixture. Plop it in there and move on. How many are you doing? That's how many fixtures you make. So that's a way to think about that. I would suggest. That's not what we want. So that would solve that problem. Grout cures overnight, whatever grout takes to cure. I'm not an expert with that, but nonetheless, there it is. That'd be the floor plate. But first, and we're not going in order, I would first be wanting to do the header. So I would have, yeah. So here's your, let's do the header component. Again, drawing and then installation instructions, then drawing. Prepare door and header according to template. We'll look at that in a moment. Fasten header portion of pivot. Fasten cover plate, the scalp plate. Fully retract pin by turning the adjustment wheel, which I demonstrated earlier. Fasten door portion of pivot. Place bottom of door on floor spindle or floor bearing. Okay, we're not there yet. Let's get the header and let's get the door prepped. Let's get the hardware attached to the header and the underside of the door. Draw that pin in. Actually, you're going to need a way to hang your plumb bob off of the extended pin. Here's the pin showing it down in the door. So you're going to need to plumb bob fixture. They called it keyboarding when I was in high school, and I said, why would I ever need to develop that skill? So you're going to need to get that plumb bob connected up on there. I could see how you might do that. I could envision you having maybe a piece of metal. Your plumb bob string is going to go down there. There's your plumb bob, okay? And then you can have the spindle sit inside of there. I mean, you're going to have to make this piece of equipment. You're going to have to drill a hole down here for your string. OD, you know, maybe just a piece of aluminum with a specific OD, a specific ID. Maybe counterbore this, drill and tap to run a set screw into that and hold it onto the spindle. That would solve that problem. You'd have to, you know, you're going to have to make this kind of stuff. I'm inspired by seeing other people do stuff. I'm not making up anything in particular. Now, what's interesting is the floor portion did not talk about a radius. The door portion does. So, in order to achieve an 1/8 of an inch in order to achieve an 1/8 of an inch margin between the door and frame, they want you to have a 2 5/8 radius over the edge of the door. If it's double acting, you'll need it to be radiused. If it's single acting, you can just bullnose. Do only one side of the door. That means you're going to use a giant roundover bit. Absolutely epically giant roundover bit. I own a very large roundover bit. Very, very large. It could be by Amana. It probably is. Let's see how big Amana gets to in terms of their roundover bits. The one I found is the big one. Well, almost. 2 1/4. Oops. I don't see a large enough roundover bit. You will have to address how you're going to account for that type of roundover bit. You're going to need tooling for doing that, is the bottom line. Doing it is easy, you know, with a large enough router and the right bit and a modified base most likely. So you're going to have to achieve that. The rest of the template is just giving you the dimensions. So yeah, mortise the door accordingly. Mortise the underside of the header accordingly. Not giving, yeah, sure, everything is here. Is it directly? No, not really. They're giving you the cover plate. Apparently the cover plate, yeah, they're giving you everything. The cover plate dimension they give you, 6.5 by 1. Cover plate, 6.5, 1 inch wide, 1/4 inch deep. It gives you the placement, gives you a depth. It gives you 2 3/4, gives you 1/2 inch. So you know where, you know, the prep in the header is going to look probably something not unlike that. That's a 1/4 inch. You're going to do the plate prep here, and then you're going to do this body prep. Super simple. And, you know, same for the door portion. Easy. What is the length? What's the width? What's the depth? Place, you know, place it at 2 3/4 and have at it. Yeah. Yeah. How long is it? Three and two. So we know it's 5.5 to here. I don't know how far it is from here over. Yeah, we're not gonna be able to assume that that's ½ inch unless it said ½ inch in two places, which it doesn't. So I don't know the overall length of that. It's 3/4 deep. I've got the arm in my hand. And yeah, it's not ½ inch. It's more like 3/8. From here over is 3/8. This thing is oops. My tape measure is too far away from me, so I'm using my caliper. Yeah, this overall length is basically 5 7/8. So it's handy to have the hardware in your hand sometimes. You know, people who mortise prep door, say I need help with a template. People who just prep the material, and I think to myself, well, read the template. It just so happens that once in a great while, the template is either missing information or it's wrong. I did a DCI roller latch a couple of weeks ago. A guy communicated to me and said, I need help. This thing is, I'm getting different data when I look at the hardware versus the template. And I dove into it, and yeah, it was not drawn as correctly as it should be. So this would be a question. I wouldn't know what to do here because I know that we're 5.5 to here. I would have to get clearance on that. 2 3/4. I know to here it's going to be 6 5/8, but I don't know what this dimension is. Oh yeah, no, I do. Wait a minute, do I? No, I don't. So based on this, I don't think I could do the job. Maybe I'm missing something. All right, now, okay, this is the bottom arm. Let's take a look at this. Prepare the bottom arm. Get it installed. Righto. Let's take a look at the bottom arm. That's fun. With door parallel to frame, place bottom arm onto spindle, rotate door approximately 90 degrees, align bearing with pivot pin, engage pivot pin. Okay, so easy stuff. So the bottom line is, what is the length? What is the width? What is the depth? And here's the only thing that you have to do math on or think about is the depth. What is your mortise depth? What is your clearance? This all has to be known. You know it's 2 3/4. You know we're 7. We are 9 1/4 overall length. We know we're 15/16. Now, over here, spindle. Now, we've got the standard spindle, which whatever is that part number. It's in the catalog. I just don't remember. Which yields us a 3/4 inch clearance. So if you've got 3/4 inch clearance, your mortise depth is going to be 23/30 seconds. Okay, that's where you're going to put that. What's interesting though is that your mortise depth is always 23/30 seconds. And the reason that's the case is because there's a variable at play here. There's two of them. Your clearance is a variable, and the length of your spindle is a variable. So what they're saying is, as your clearance changes, so must your spindle. As your clearance changes, if your spindle didn't change, you would simply modify your mortise depth. So let's say, here's what I'm driving at. If you've got the standard package, but you don't have a 3/4 inch clearance, yours is 5/8, okay. Increase the mortise depth by 1/8 of an inch. I'm sorry, 1/4 inch. Oh, no, 1/8 of an inch. 3/4 to 5/8, and then 1/8 of an inch. You're just going to make that prep deeper because you've got a tighter clearance. Let's say it was 3/8. Okay, increase your mortise depth by 3/8. 23 30 seconds plus 3/8. Now, when you're doing the job from scratch, you're going to order the right spindle. You'll specify CP1000 by spindle and call that out. But if you've got a 3/8 clearance or a 1/2 inch or a 5/16 clearance, you're going to have to play with your mortise depth, and that's how that's done. It's not obvious. They don't tell you that that's how you would do that, but that's how you would do that. You're going to definitely want to just have the proper spindle length. And the fact of the matter is, could you make your mortise depth shallower? Let's say that you had a 1-inch clearance, but you had the standard spindle. You could decrease your mortise depth by 1/4 inch. The problem with that is your arm's going to poke out. But six half dozen the other. You could do that as well. It's not recommended, but just let the hardware solve the problem. And that's what I have to say about these installation instructions, and they're pretty simple and straightforward. So let's wrap up this video on camera. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience, and hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. So thanks for hanging out with me on this CP1000. I am a fan of pivots. I will often promote that people consider using them. People will say, hey, I need a way to hang a door. And the first question is, how heavy is your door? Well, it's 400 pounds. I was thinking, I thought I better use those heavyweight hinges. Pump the brakes. There are no standard heavyweight hinges. Well, I'd have to look at the chart, but you are in the realm of, let's not think about butt hinges. There are butt hinges that will hang a 1,000-pound door. I've got them in stock. But butt hinges really aren't the way to go, because it's known that 70% of the weight of the door is borne by that top hinge. Oh, there's a shim here. I didn't see that. Not a shim, it's a gasket. That's probably going to go over your... Yeah, that's going to go under your cap, this little black gasket. So 70% of the weight of the door is going to be held by that top hinge. Your bottom hinge is doing next to no work. So considering butt hinges for anything heavy is just not the way to go. So don't go that way. Think pivots. Pivots are elegantly positioned to handle exceptional weights. This is a 1,000-pound pivot. I don't have it in stock right now, but a 3,000-pound pivot is something that we've sold in the past. That's a monster piece of equipment. Pivots are generally going to be your 200-pound doors. That's actually, for commercial pivots, that's what's going to be considered, in my experience, really the low end of pivots in terms of weight. After that, you're getting into the 300, 400, 500-pound range when it comes to pivots. That's pretty typical and common. After that, you're going to be dealing with either jumping up to 1,000, or in the case of Dorma having a 660-pound rated piece of equipment. And, you know, again, that really is going to be a lot of determining what's the weight of the door. But when it comes to deciding which is the appropriate pivot to use, you do have to think about, when it's center hung, what do you have to do to contend with the fact that it's center hung? You have to make arrangements to weather strip an exterior door. You have to potentially bullnose or radius the edge of a door. A lot of that may simply not be possible for what you're doing. You may not have the luxury of radiusing a door. You might have a 2x2 welded steel tube structure, and by the time it's done, it's 700 pounds. The hardware is going to be mostly surface mounted, but you're going to have to think about how you're going to do that. There's ways to do it. You can buy steel that is radiused and tack weld that on. Hollow metal door manufacturers do that. But some real creative thinking is going to have to get kicked into play here to determine exactly what you're going to do, how you're going to do it. And as it's been said to me by people in the hardware industry, the real experts, when you are in the hardware industry and you're initially learning how to coordinate material, it's been said to me, and I've said to countless people, look at the installation instructions and get the hardware, get it out in front of you, understand how it goes together. If you can do any field work, do that. So earlier today, I installed an aluminum, continuous geared aluminum hinge on a door. My son and I, we went out and installed a door closer, removed the pivots from an exterior aluminum storefront, a Vista wall. These pivots were worn out 10 years ago. Pulled those out, slapped on a continuous geared hinge, installed 2 door sweeps and then a door pull. Well, I can guarantee you that my son, who installed the door sweeps, which was his first time, he can now speak to you. Here it is. I was looking for that for half an hour earlier today. My son can now speak to you intelligently about how you install a door sweep. You get it, sure, you cut it, you screw it, blah, blah, you're done. But when it comes to the intimate understanding of the process of how you approach a piece of hardware from the perspective of not only seeing the hardware, looking at the instructions, looking at the template, but then taking the approach of the person who has the experience of installing it, now you can predict, now you can reliably tell people, here's what you'll encounter. Door sweeps are one thing. A surface-mounted parallel arm closer, okay, yeah, that takes some skill. An aluminum geared continuous hinge, they're easier than people might think. You get into exit devices and function holes, and then pivots. Yeah, the better that you can get involved in terms of setting the material in the floor, gaining the experience, the better you're going to be able to understand the totality of the job, what's actually required to take this from someone's imaginary fantasy concept all the way to getting paid. And when it comes to pivots like this, especially those that sit in grout, going to need to think all that through. How am I going to do this? How am I going to do this? I have several times gone through a procedure mechanically, mentally. I would literally go every step of the way, and I would take notes in terms of, at this step, I will need this, I will need this, I will need this screw, I will need this tool, and make those lists, and then I would run through the procedure again. Is it overkill? No, it's not. I have successfully installed 22-foot length wooden structures that will act as a bridge. I've put in a 12-foot set of stairs, and everything just thought through the first time, assemble all the products, prep all the material, start installing it all methodically, and that's my approach. Because at the end of the day, getting paid is the point, and if it's not correct, that usually interrupts the getting paid part of the equation. Dorma's a great company. They are, I don't know how many decades old they are. They're now called Dorma Caba. Under that umbrella is going to be the traditional Dorma name, the closers, the lock sets, the exit devices, and pivots, and electromagnetic holders. But also, Stanley hinges are going to be under that umbrella, which are now called Best. Yeah, Best Lock. They're now, Stanley hinges are now stamped Best. Best Lock Company is under that umbrella. Precision Exit Devices is under that umbrella. And there are other companies that are as well. I think Rutherford Controls is as well, amongst, I'm sure, other names that I just am not familiar with. So if you have any questions on the CP1000, you can kind of see them. I've got another, right at the tip of my hand there, I've got some CP660s as well, and I've got CP440s in stock. We endeavor to have odd things in stock, odd hinges, heavy hinges. If you needed a hinge for a 1,000-pound door, I've got it in stock. If you need 8x8 butt hinges, I've got those. If you need pocket hinges or Harmon hinges, I have those. If you need a 1,000-pound center hung pivot, I have that. Because I find that people get this door made and then, oops, I have to install this next week to find out that it's an 8-week lead time because the hardware that you want is incredibly unusual. Anyway, keep us in mind, and thank you very much. Bye-bye. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you. Thanks to our clients, Architectural Builders Supply is building an additional facility, and what follows is not only a look at the acreage that we're building the facility on, but also first the architectural renderings as they exist, or at least the architectural plans as they exist at this time. Thank you very much. Let's take a look. All right, let's take a look at the architecturals as they exist at this moment, or at least it wouldn't be proper to call these architecturals, but it would be proper to call them renderings in the sense of they're conceptual drawings, they're not renderings. So the entire space is going to look like this in terms of a site rendering. This will be a 22,000 square foot building, of which we'll have specific purpose areas. There'll be a workshop down here. This is a few thousand square feet that will be likely woodworking, metalworking, CNC, things of that nature. This will be an office area here, a private office area. This will be Architectural Builders Supply expanded storage area where we will be able to do fulfillment. The entire space in the center is going to be all of the volume, as I call it. Large components will be able to be stored in stock there. Machinery that's too large to fit otherwise may be put out here. Specific facility rooms, and then some recreation over here. Let's take a look at that drone footage, and thank you very much for taking a look.